Hello, everybody. I'm Velu Saboya. I'm a developer advocate here at AWS. Welcome to the latest episode of the AWS She Builds Tech Skills EMEA program. So, this is a program that actually seeks to build your skills and your career on the AWS cloud virtually by offering you programs like this one where you can actually learn from others. And during this show, we actually have hands on discussions where you can actually learn and see how others just like you actually learn. And as usual, I'm not alone. I am with my co-host Antonia. Antonia, I'm going to hand over to you.
Perfect. Thank you very much, Veliswa. So yeah, I'm Antonia. I'm a data scientist with the Machine Learning Solutions Lab team here at AWS, and I'm one of the co-hosts today. But the rising star today is really Elizabeth. She's our expert. She's a software development engineer at Amazon, specifically at Amazon Alexa AI, based in Cambridge. So Elizabeth, to kick off, my first question would be, since you're working at Alexa, do you actually own an Alexa device?
Yeah, I do. I actually have like more than one Alexa device around my small house. So we have like one with the spot, like the small clock kind of size, and then we have the one with display, the bigger one.
Awesome. And can we expect some Alexa turning on during the stream right now?
But I have disabled Alexa because it will trigger every time I'm Alexa. So yeah, it's disabled.
Yeah. Awesome, perfect. Yeah. So please tell us a bit about what we're learning today from you.
Okay. So yep. Hello everyone. So can you today I will be talking about Alexa AI. So first of all, let me introduce myself. My name is Elizabeth Kwan. I'm currently based in Cambridge, UK. So I will share some of the AWS technology here we use here in Alexa to make Alexa more knowledgeable. So in order to go to the AWS like the demo bit, I will have to explain what is like knowledge, what is Alexa, how do we process knowledge in the Alexa briefly before we jump into the AWS demo. So I hope you guys will enjoy it. So I will first open the sessions with a small quiz. So let me know if you have know the answer, Antonia or Felisa. Do you know who was the prime minister when Ed Sheeran was born?
No idea.
Right. So yeah, this type of questions is interesting because we as a humans, it's easy for us to kind of we don't know. Maybe we don't know who Ed Sheeran is, and maybe we know who Ed Sheeran, but we don't know when he was born, and then we don't know like what is the prime minister? Is it like you are talking about UK prime minister? I mean, like we are assuming because I'm based in the UK, like I mentioned earlier, that the prime minister here is the prime minister in the UK. But for this kind of like simple question for a human, it is difficult for Alexa to actually like understand and able to give an answer, even though Alexa might have this information. So today, next, I will briefly explain how Alexa answer these types of complex questions, we say, and using what kind of the technology in AWS. You will know the answer towards the end of the presentations, who was the prime minister. So, like I mentioned earlier, for Alexa to understand the questions and to be able to answer, Alexa needs to understand what we say. And then Alexa then can respond with the accurate knowledge of the world. So in order to do this, Alexa also need to have the accurate knowledge of the world. And then we store the knowledge in something that we call knowledge graph. So it contains all of the information about the world, about like, okay, Ed Sheeran is a class of human, he is a human, then thus he might have some attributes that humans have. And he is also a singer, that he has attributes of a singer has. We store this kind of information and what we call knowledge graph. So let's deep dive a little bit deeper into what is knowledge graph. So knowledge graph is a digital representation of the world. So of course our world is very complex. So and then we try to make it simplify, try to make it to model the world in the entities way. So knowledge graph is actually something that is very common that is used to in the natural language processing world. So this is a simplified example on how we model the knowledge of companies in the knowledge graphs. So we have companies like Amazon, Apple, Twitter, etc. So we know companies are kind of like similar to each other. They have, even though some might be private, some might be public, they all at least have the same similar attribute. For example, they will have the name, they will have a headquarter location, they have like founding year, they have some executives, CEO. And then on the right side, we have these executives sets where it is, we have all the executives and who might have worked at many companies, and then we connect these two sets into some relationship. So, for example, we have like, this is just an example. Tim Cook is the CEO of Apple, and then we further enrich each member of this set with the properties. For example, executive will have tenure, compensation, educational background, and so on. So this is kind of how do we model the work. So all of these things in the world, we call it entity. So let's go back to the previous example. Ed Sheeran. Ed Sheeran is an entity. His birth date is also an entity. So we group similar entities into collection of larger entity classes like singer, heads of states, executives, country, and stuff. So like in the previous examples, and each of this collection will have set of common properties or attributes. So for example, Ed Sheeran is a singer, thus he has this song. Head of states or like executives might not have this relation published a song. So this is tied to his attribute as a singer, his class as a singer. So this is how kind of like slightly what is knowledge graph and how we map like the knowledge of the world into this kind of like digital world.
I think I have a question. So thinking about the universe and how much fits maybe into my human brain, can you disclose how many nodes there are in the knowledge graph from Alexa? Because if I mean, we're just looking at Ed Sheeran and we already have two entities. So thinking about what Alexa all needs to know, how big is that knowledge graph then?
I don't have a number, and then I cannot actually give. I mean, like I don't have. It keeps on growing every day, so I cannot have the number. I cannot give the number to. But it's growing every day. You can imagine it will be very, very big. That's why we use AWS, because it is big, and we need to process it. So when you talk to Alexa, everything happens in milliseconds. You cannot just like do something like retrieve this information very slowly. We have to do it like in high performance. That's why we use AWS.
Cool.
Right. Yep. So that's about the knowledge graph. So looking back to the first question we have in the opening session, in the opening slides. So we go back to this question: who was the prime minister when Ed Sheeran was born? So in order to understand these questions, we need to understand the entity. What is the entity here? Like this is another entity, another process. And Alexa, I will not go into the detail here right now. So Alexa will, okay, we are talking about Prime Minister Ed Sheeran, and born is like birth date. This is called like entity extractions, and then we will link to this Ed Sheeran. So for example, there are like hundreds of thousands Ed Sheerans in the world. We need to know which Ed Sheeran we are talking about. And then this is process called entity linking, which is also happen behind the scenes, not also in this part of the talk. But that's a process where we need to know like what is the entity. Then then we also need to understand the implicit cue in the natural conversations, for example, as locations. So when I ask as Prime Minister, because I'm based in the UK, I'll probably ask the Prime Minister of United Kingdom. So it's unlikely I'm asking about Prime Minister in New Zealand or like a country that without Prime Minister, for example. And then after then, we need to have some information of when Ed Sheeran was born. Like Ed Sheeran was born in 1991. And then Alexa has this information of like the Prime Minister of UK. So for example, this Prime Minister elected from this date and then until this date kind of thing. So Alexa has the information of like John Major was the Prime Minister of UK from 28 November 1990. And Alexa also have another information that John Major resigned on 2nd of May 1997. So here comes like the inference and the logic behind it. not only Alexa pulling these informations from the knowledge graph, but also do some kind of inference behind it and try to reason, okay, this time point overlap with this time period, those kind of inferencing happening. So Alexa then answer, you can try it later at home. Alexa will answer. The closest answer I know is from the 28th November 1990 when the Prime Minister of United Kingdom is John Major. So Alexa will try to give more elaborative answer. So like not only John Major, because we can try to explain the thinking. Okay, it's John Major because we know from this data to this data he is the prime minister. So these all things powered by knowledge graph.
So I'm very curious, who does the localization there? Because when you first asked this, I thought Prime Minister of what country? But you do say there's localization that happens. Who does that? Does Alexa do that, or do you have to further go and explain yourself before Alexa can figure out that you're talking about Prime Minister of the
Oh,
UK?
Alexa do it in
They do that.
yes.
Okay,
You
great.
can infer the location. For example, I ask Alexa right now here because the location I'm in the UK. So it kind of like find the locations in my Alexa devices. Okay, she knows I'm based in the UK, so I'm asking about the United Kingdom. But if I ask for specific questions like who was the Prime Minister of New Zealand, for example, then Alexa will fetch the Prime Minister of New Zealand. So it implies behind the thing the same.
Very, very interesting.
Yeah. Um, that's how Alexa work behind the scene, and we will go into the topic, and then that will lead to us to demo how do we make Alexa more knowledgeable. So what we do is we continuously update our knowledge by adding more data into knowledge graph, so which just makes sense, right? Like the more data we have, the more knowledge we have about the world, the more questions we can answer, right? So this process we call it knowledge acquisitions. So there is an independent team that do kind of like extract the knowledge from external sources like web pages, IMDb, etc., and then encode and ingest this knowledge into the knowledge graph, right? So traditionally, knowledge graphs were built manually, so it's a lot of like handcrafted and like human involved. For example, we have Wikidata, which is like the biggest one, which is the collaborative edited knowledge base, which is also needs a lot of like human expertise there. And as we know, this is not scalable. So at Amazon, we need everything need to be scalable. So all of this process actually happen behind the scene, and it's automatically happen in pipeline. So there is no like kind of human intervention or interruptions. We try to have like as minimalized, because like when training and stuff, still human might need to be involved, but it will not be like we are writing stuff directly into the graph, like, okay, update this data. Oh, Ed Sheeran released a new song, I have to update the graph and stuff. No, it will happen automatically behind the scene. And I don't know, I mean, even as the engineer, we don't know when the data will come. And it should be happen as quickly, because, for example, in UK recently, we have a new king that has to be kind of like updated. So we don't want to get delayed. This happen behind the scene, and we don't even know like when this data come into graph. It's just there. It will just flow from the stuff, right?
So that's insane. So you're continuously updating the knowledge graph.
Yes.
Wow. Okay, that really needs cloud computing then.
Yes, definitely. That's why the AWS come into places, right? So I think that's all I have about the brief introduction about the knowledge graph. Because today I will not go into the how we acquire the knowledge in Alexa. Um, I will go into will dive deep into an example of creating simple knowledge ingestion pipeline with AWS. So this is not the actual like pipeline in Alexa, but with this pipeline you can kind of like have ingesting some facts, some knowledge into some store. And as you may know, Alexa, like any other Amazon products, is powered by AWS. So all of our infrastructures are in AWS, which is really make life is a lot easier. Okay.
So while you are switching, Elizabeth, I just want to ask all the people that are watching if you've got any questions just to remind you, please post them in their chats and we will make sure that Elizabeth sees them and then we can discuss whatever you are curious to hear about.
Thank you, Felisa. Yeah, so before I go deep dive like and switch to my AWS console, I will talk through about like what are the workflow, what are the components involved. Assuming not everyone familiar with the AWS technology we use here. So here's a simple illustration on how ingestion workflow with AWS may look like. So in this case, we have a publisher. So it might be some other team or some other process that already extract the knowledge for us, and then it will pass us to this publisher, which affected is ready to be ingested to the knowledge graph. Um, so publisher will send us, we are using SNS topic here, and to notify, okay, there is a new fact that is ready to be ingested. Then this SNS will push these facts to the SQSQ. So we will have all the facts that are ready to be ingested line up in the queue. This is a pub sub model, so publisher and subscriber model, so we can between this SNS and SQSQ. Then after that, we have these facts ready in the queue. We can push this to Lambda, which is the will do kind of pre-processed bit and go into the DynamoDB, which we store the data. So we use AWS all the way. If you are not familiar with this like technology, don't be afraid. I will slightly discuss this, not into deep dive to each of the components because it might take like hours for each component itself, but slightly explain what is this and how do we use it in for these examples. So first component we use is SNS, Amazon Simple Notification Service. So we call it SNS because that's the short for it. It's a fully managed messaging service for both application to applications and application to person. So you can not only send message from service to service, application to application. In this case, but you also can notify someone or like service or like send an email even with SNS. But in this case, we will use this like for publisher to notify us. Okay, there is a ingestion ready to be processed. Next one in the component we have Alexa Simple Queue Service or SQS. So this is a fully managed. It's again a fully managed message queuing service. So using SQS, you can send, store, and receive messages between component without losing the messages or like requiring all the service to be available. So it'll just be there. So the idea is like we don't want this. So for example, the process that process the facts not available for some audits, for example. We don't want the facts to gone, right? Like because this is extracted somewhere. We want to have it stored in a queue where we make sure that this can be delivered to the other stuff. So we need to use queue to to line up all the facts that are ready to go. Then we will use Lambda. Lambda again, very useful. It's a serverless, event-driven compute service that lets you run code without provisioning or managing servers. So I like Lambda. You don't have to provisions, so you don't have to care about how many fleets I have to process this. And this is very suitable for like a short running kind of like code that can be run in Lambda. So in this example, we have like only one Lambda, but in the real application, we can have a multiple Lambda that call to each other and stuff and more complex. So it's really like it's a building blocks, like it's really convenient to have. So
Yes, it's a lambdas in every demo that we have. You can't
right,
think
right,
of
right.
AWS
That's
without
very
using lambda.
the good one, yes, right? So use Lambda function to process the data into the format that is known to the knowledge graph. So the facts probably in some format, and then I mean maybe it might be come into some like a line or like a sentence, or it might be come. But the way we store it in database will be different, right? So we will have it stored in a more like compute efficient way, so it will be easier to track on for DynamoDB. We use kind of a partition key and stuff, indexing and stuff, so make it like really fast and to do this to does this pre-process and make like the sanitation and stuff happen in the Lambda. It, Like the last bit of this component is DynamoDB. Again, DynamoDB is fully managed. It's serverless. We use key value pair, so it's a NoSQL database that is designed to run for high performance applications and at any scales. So it's fully managed. It's serverless. You don't have to provision. So it kind of like do it automatic. You can do automatic provisioning. So it kind of like know your load and then it can scale. So we previously use different technology before when we have to scale up manually and stuff. But with DynamoDB, it comes like really easy. So DynamoDB not only it works for high performance, but it also it comes with a lot of features like built-in security, continuous backups, which we need, right? Replications, automatic multi-region replications, in memory caching, and data import and export tools. So this is really important for us because we don't. Hi from London. Hi from Myanmar too. So we want to have this data, make sure like we don't lose the facts and we have the backup every time. And then high availability because it's 99.99. It's
Yeah.
99. So that's the thing that is always available. That we want to have, make sure that we have. So we store our knowledge graph in the DynamoDB, and because data lookup should be very fast for a knowledge engine to serve customer without significant delays. Yep, those are the components.
Can I just ask one quick question? When you ingest new facts, does fact checking of the facts happen before the publisher actually even pushes them through? So where would fact checking actually happen here when you receive a new fact? That would be before the publisher publishes, right?
Yes, in the simple case, because we want to, this is like actually like the actual data pipeline, but it's like simplified versions with a lot of stuff. So
Yeah.
really, we have a lot of consistency check when we extract the data. We make sure this fact is correct. What happen outside
Okay.
the ingestion?
Great.
When we ingest, we know these facts are good. So here's the assumption: the facts are good. We trust the publisher. We already
Perfect. Thank you.
yeah, and the pre-processing here just to make like a little bit sanitized checking
Yeah.
or go to the that might be some kind of like ASCII problem or stuff like the in those in the process that we might want to filter and stuff before go to the database. Uh, okay, if there is no further questions, I will switch to AWS my AWS console.
Time for a demo.
Right, demo. So I'm using a burner account here. Right. So we will start and by creating one of each components. If you can see there some all the components because I did rehearse this before. That's why it's show here. But you can type here. For example, the first step will be will create the SNS topic. So you can type SNS here. Okay, yeah, it worked. Is it confused? It usually not this slow because probably um, let me try again. Is my connection kind of a bit slow here? So you can type actually here. It will show up usually. Very oh there it is. Might be glitch. So you can type SNS and then it will show up here. So we can create the topics here. We don't have any topic. Create a topic. There are two options, FIFO and standard. We will go with standard this time because for the facts, we don't care about the order. I mean, it doesn't matter which fact comes first. It will be the same. But if you care about the order, you can choose the FIFO. Rename it to knowledge ingestion topic. Yep, and let the other setting by default. Of course, you can configure, but this is just an example. Now we have our first topic. So let's copy this ARN because I will use it later. So now we have the first topics, then we want to create the second one. We want to create the queue, like the second component here. So in this page, we want create queue. Again, I choose the standard because I don't care in particular exercise about the order. We use this name simple and JSON queue. Here in the configuration, you can set up a lot of things. Like for example, you can set up the message retention periods. By default, it's 4 days. You can choose seconds, minutes, and even hours. And if or you can also choose delivery delay. So for example, after receiving the message, you don't want to process it directly right away. You want to send it by some delays. You can do this. Visibility timeout, maximum method size. It's all configurable. So we will let it use the default value here. Of course, and enabled in encryption. Want to make it sure the data is safe, and using SQS SSE encryption key, which is managed. So we don't actually have to manage. Policy, just the default one. Okay. Now we can create the queue. Right. Copy the queue here. We will use it later. So now we have the SNS and we have the SQS. We want to link the SNS to the SQS. So see, I think this is leftover from the previous example. So we don't have, you don't see it, we don't have it linked. So we need to link the SQS to SNS by doing this. So you can just come back, go back again in the queue. This is our queue. In the SNS subscriptions, click subscribe to SNS topic. Then we can choose which topic we have, and then if this is the first one that we choose, the knowledge ingestion topic. Right. Now we have this is connected. If we go to our topics, it will say it is also subscribed to this queue. So then we have this SNS and SQS connected. We can use, we can test if it works. Do the small test here. I'll do some stuff. So this is, I will send a raw message in JSON. Just use JSON for because it's nice. It doesn't have to be JSON. It can be only string. So publish the message. It says message published to the topic successfully. Nice. Now in the simple ingestion queue, we want to see, send and receive a message. We need to call for a message. There we have it. Right. So this is what we sent earlier in this format. It come with other embedded from message ID and stuff from SNS. We want to stop calling. Delete this for now because we will do this automatically later. So that's how we test. We have SNS and SQS working now. Nice.
The next step is then connecting the Lambda function as well as a trigger.
Yes. So the next thing we will have to connect this to the Lambda, but before connect to the Lambda, we want to create the DynamoDB table first, so we can store the stuff and then we can test it from Lambda. So in DynamoDB, we can choose a create table. This is very simple DynamoDB table settings. So choose the nums. We have this partition key set up. So this key is already set up because I have a code ready that will read this key name. So it's I use KG key here. I use the default settings, but basically you can choose what is your read capacity unit, what is your write capacity unit, depending on how big or like how. So if you are like read heavy or like you are write heavy, then you might have different settings. So let's go just with the example, the default value. Okay, it's creating now. It should be completed successfully within a minute. Yeah, it's active actually. It's just seconds. Now we already have SNS, SQS, and DynamoDB. The bit that connecting this together is Lambda. Right. So we want to create a Lambda functions. In this case, we want to create it from the scratch. You can use a blueprint. There's a lot of blueprints that you can use, but I want to use it because the example is simple. And I use Node.js. But there are a lot of other languages support here: Python, Ruby,
First
Java.
time we see Node.js, I think, in the tech skills program.
Yeah, I think people probably prefer kind of Python. I see Python.
Exactly. Regular
Right?
data scientists.
And there is a reason why we use Node.js, because we use also AWS CTK, which is also in TypeScript. Also, you can do in Python, but it's
Yeah.
kind of a lot of support in TypeScript, which is also Node.js. That's why it's easier to have like one language, but definitely you can use other language here. It's easy. Um, then for Lambda, this is important because we need to create a role that allows Lambda to pull from SQS, and also for Lambda to write to DynamoDB. So we need to create a new role here. I will give the name. Okay, policy templates. So we can find simple. Yeah, this is DynamoDB. Simple microservice permissions, and also SQS. Amazon SQS folder permission. So these two will allow the Lambda to create the functions, to write and read. Okay. At this point, there is no code involved. It's still just basically creating a Lambda. Okay. Now we have the Lambda functions. So the next bit is to have the code. I have the code ready, so I will just copy paste. We can go through the code here. So the code here is very simple. This is like one liner, like kind of very simple. We will have a DynamoDB read document variable cons here, so that we can write into DynamoDB. We use US is one because here is US is one, so you can change the region later. And then once we receive the message from the SQS, we will parse, because again I use JSON here. That's why it's easier. So then I will pass and then do some check. If for example somehow if the fact ID is empty, left relation right empty, then I will not pass this stuff. And then this is the table name for the DynamoDB. Then we will write to DynamoDB. So yep, it will be very simple to read from SQS and then to write from DynamoDB. We will deploy it. It's nice. If you make change and it hasn't deployed, it will be notified there. Okay, I guess that we have all the components together. Now is the moment of revelation. And yeah, here it's connected to SQS.
Yeah.
Oh, right. I need to enable this from. So this was from the previous work I did. Let's start over. That's why I was like I skipped this process. So let's start from the beginning. We don't have the trigger. So in the configuration trigger, we will have right. Let's refresh that bit first. Okay, so we don't have a trigger. Now we will need to connect the Lambda to SQS. I thought, wow, that's happened automatically before I did this. Not too fast. We have the SQS here, so we choose SQS queue, and then we choose which queue that we want to add for this Lambda to trigger this Lambda. So it can be as SQS, it can be so Lambda is event driver. You can use any trigger behind the scene, but in this case we want to be this Lambda triggered by a message from SQS queue. Yep, I guess we choose the default size by default. Right, now that we actually have the SQS. It's still in the creating process, but it will change to enabled in a minute.
Elizabeth, there's one comment from the audience. It's around, why do we call it code? We use JavaScript to write code, or do we use JavaScript to write instructions in JavaScript?
In this case, we use JavaScript to write codes. In this
Yeah.
case, right? Um, JavaScript is also a code. As I mentioned, you don't have to use JavaScript. You can use Python, but this is very straightforward. I think it's easy, and TypeScript actually, I think it's more like TypeScript and rather than the JavaScript that we know that we are using here. Yes.
We also have another question regarding which programming language to start with to learn coding in general, and also for using it with AWS Lambda. And I would actually recommend to think where you want to go to, whether you want to become a data scientist, then probably try to go for Python. But if you're going more into the software development engineer, then JavaScript might indeed be a better language. So it really depends on what's your professional job that you would like to have in the future.
Yeah, I want to add on top of that things, because AWS is really good. I mean, you are not limited to the language. You can choose a lot of language, so it doesn't have to be like JavaScript. Just in case in this example, I use Java, I use Node.js, I use TypeScript, but you can use Python. You can use whatever other language.
Exactly.
A lot of languages supported in AWS, so I think programming language should not be the problem.
Yeah. All right. Let's get back to the demo.
All right.
Are we ready to publish now some facts?
Yes. So it's enabled now after the questions. Nice. So now we can try. Hopefully it works. Finger crossed. Go to the LNS stuff. We can publish a message. So we do this manually, right? But in the real world, no one actually sending these things. It's either service, either application that send us the message automatically behind the scene at all time. So this is just the demo here. It says we are successfully published this topic to this stuff. Okay, let's see. Okay, hopefully we have. See here, we have the data in the knowledge graph.
Awesome. So now if I ask my Alexa device, it'll give me an answer.
Yes. Now that you have the data in the knowledge graph, that it becomes easier for Alexa to process the data. So this is a very simple example of how do we do ingest data, and we do it every day, every second. I mean, we do push a lot of data there.
Awesome. Well, thank you very much.
Amazing.
It was really a nice demo, really crisp. So everybody knows now how to build a knowledge graph. That's cool. And I think, Melissa, you still have something planned, right? You have some events lining up for us, correct?
Yes, I do. So, if you've been following the AWS Game Day World Championships, we're now at the finals. We had qualifiers per region. We had qualifiers in EMEA. So if you're watching, you had 3 opportunities to actually compete. And we had in APJ, and then we had in the America region. So now we're on to the moment of truth. Finals are happening tomorrow. So even if your team, you did not enter and your team is not in the finals, you can tune in and still watch and just follow everything and see who actually gets to win opportunity to attend a reInvent in Las Vegas at the end of the year. So that's the one announcement that we have for you coming up. And then next we have let's see if my screen has actually moved. The next one that we have, the next announcement that I have for you is there. Okay, my screen is not moving, but let me just talk through it. The next one that we have coming up on the 6th of October, which is next week, we've got AWS Innovate Online. So this is an online session that we have. We've got different sessions that we have, breakout sessions. The entire theme of this event is run every app on AWS. So we will have sessions for you ranging from storage, from databases, from computes. You want to make sure that you watch that as well. You can still register to watch AWS Innovate online next week. We will share the link for you in the chat. If not, we'll find a place or some way to actually share that link for you so that you can still go and register. And then we've got the date confirmed for our next, this will be our final, not our final, for our next episode happening. It will be at the end of October. Let me just look up the date for you very quickly, seeing that my screen is just wanting to let me down today. And the date is there.
26th.
We've got the
October, right?
25th. It's the 25th of October? 25th of October. So for now, we will still confirm all the other details for you, but save that date to make sure that you don't miss our next episode that is going to be happening. We'll have a new guest and we'll have a new, very amazing topic, just like the one that we actually had today with Elizabeth. So we'll see you then. Thank you, Elizabeth. I really, really learned a lot today, and I really did enjoy the walkthrough that you gave us here.
Thank you.
Thank you very much for joining us. And also thank you for all the people behind the scenes making this stream possible. It's great to be with all of you. And see you next time.
Thank you. Thank you, everybody who watched. Thank you again, Elizabeth. Thanks, everybody.
Bye-bye.
Bye-bye.